Okay, so 2.5 day 2, we're going to continue with complex numbers. Do you guys remember what complex numbers are? What are the new numbers we learned about? Yeah, the imaginary numbers. So complex numbers, just combine the imaginary and the real numbers together. There's a certain form for them. Do you guys remember what that is? What's the form of a complex number? Yeah.
Isn't it like A plus BI?
Yes, A plus BI. A is the real part. The BI is the imaginary part. Okay? So when we're writing out solutions to complex values, we are going to be writing out A plus BI form. And we're going to be finding complex zeros today. Okay, so we're going to find complex zeros, and we're going to use the method of completing the square. Okay, do you need any more time for the headline today? Okay. All right, so for the first example, we're going to find the values of x and y that make the equation true. Okay, that make the equation true. And there's just 2 steps here. And then something else we want to notate for today is whenever you are finding the solutions need to be exact and simplified. So that's not something that's always explicitly stated in the directions. Like in every single direction, it's not going to say they have to be exact and simplified. That is just our proper form for this. Okay, so when it says exact, we're not rounding anything. Okay, so you're not going to have decimals here. Alright, so for part A, we have 4x plus 10i equals 2 minus 4yi. So we have to find the values of x and y that would make this a true statement. All we have to do for this is we have to set the real parts equal to each other. And then solve. So set the real parts equal and solve. And then we're going to do the same with the imaginary parts. Okay, so you find the real parts, set them equal to each other, and solve. And then we're going to do the same with the imaginary parts. Okay, so for A, the real parts are going to be anything that doesn't have an I in it. So it would be 4x on this side. And then on the right side, it's just going to be 2. When you're doing this, you do have to be careful. Like sometimes there could be like a number behind the I term, and that's a real part, so you would use that. So this is 4x equals 2. And then all you have to do is solve for x. So divide both sides by 4. X would be 1/2. Okay, now we're going to do the same with the imaginary parts. So here I have plus 10i, and then the minus is important here because you do have to take that negative with it. So if you have 10i equals negative 4yi, okay, with the imaginary parts, you should always have an I on each side. And your first step is going to be to divide by I, because you're trying to get y by itself. So if you're trying to get y by itself, when you divide by I, that just divides to 1, so this is 10. On this side, I have negative 1 times 4y, which is negative 4y. And then to get y by itself, I would divide each side by negative 4. And then I'm going to simplify. So 2 goes into both, so I'm just going to reduce. So my y value is negative 5 over 2. I'm going to leave it just like that. All right, so based on A, I want you to try part B. See how we did. All right, so for the real values, Danny, will you tell me what you set up for your equation?
Negative 8 equals 5x.
Good. Okay, so this is real, so negative 8 equals 5x. And then what did you get for your x value?
Negative 8 equals 5.
Good. Okay, so divide both sides by 5. X equals negative 8 over 5. Okay, awesome. All right, now let's go to the imaginary. So, Dane, what did you set up for that?
6y, I,
Good, and then did you remember to put the negative in front?
I.
If not, let's add that in. Okay, so if there is a negative in front, you do have to take that with it. Okay, first step is just going to be dividing by I. Okay, and if you set this up correctly, they should cancel, so you have negative root 6. Okay, Rashawn, what did you do when you got here?
Divide by 6 on both sides.
Great. Did any of you think of doing something different? Did any of you think of like squaring both sides? Okay. You could do it, it's just a lot longer. Okay, so to get y by itself, you divide by the 6. Okay, and then you have negative root 6 over 6. All right, and then like I said, sometimes, like in your homework, they might have like 5x minus this and then plus like a 2. If you had something like that, you would just put the 5x plus 2 here, and then you would solve it for x like normal. Okay, so sometimes all the real parts aren't next to each other. And like I said, you'll have time to do your homework today, so if you have questions about that, let me know, and that can be something we can do together, okay? All right, other questions for me for example 1? All right, let's start solving. So this, it says, find the zeros of each function. Okay, find the zeros of each function. So we've done many things that are similar to this. Finding the zeros, what are some other directions that have the same effect as finding the zeros? What might they tell you to do? What are zeros?
The intercept with the x-axis.
Yes, good. Okay, so the intercept with the x-axis, so the x-intercepts, absolutely. So the zeros are x-intercepts. They're also called what? Starts with an R. Grows on trees. On the ground, technically. Roots. Okay, so x-intercepts roots. Okay, sometimes it just says to solve. Okay, and that's what you're finding. The zeros, the x-intercepts, and the roots. Now, we've actually gone over many ways to find zeros. How to find zeros. Okay, what's one way? Wow. How do we find zeros? We just did our quiz on it.
You can factor it out and set it equal to 0.
Yes. You could use factoring. Set it equal to 0. Find the roots that way. Yep.
Opposite of b over 2a. That's how you find x, and then you plug x in and find y.
Okay, and then that would only be 0 if y was a certain value. So that would be the vertex.
Oh.
Rashawn, you remember? How else do we find zeros? That would be the y-intercept instead of the x-intercept. Right? So x is 0 when it's a y-intercept. You could set the equation equal to 0, and then how would you solve it? So one way is factoring. What's another way that we did? If they're x-intercepts, what can you look at? Where do you find x-intercepts? On the graph. Didn't we graph things? I remember doing that. We can find the graph, and then we did two things with that. You can either look at the graph itself, right, and you find the x-intercepts, or remember we also did this with a table. And in the table, that's where we would find where y is 0. And then the last way, the way we've been working on this week, is completing the square. Yay, completing the square. Now, if you read your paper, you can see what method we're using. We're using completing the square. Okay, but some of you might be thinking, well, why do I have to do that, right? It just says find the zeros. Technically, you could use any of these ways. Okay, if the direction on your quiz just said to find the zeros and didn't tell you which way, you can use any one of these. So for A, let's talk about factoring that. If I was factoring, I'd have to find two numbers that multiply to 26 but add to 10 because they're both plus. Well, factors of 26 are 1 and 26, 2 and 13. Are any of those going to add to 10? Okay, so we can't factor. Well, what about the graph? I know some of us, if we had trouble factoring, okay, you were like, oh yeah, guess what? I can find the x-intercept, and that can help me factor. That's true. Okay, so let's graph it. X squared plus 10x plus 26. Now when I graph it, what am I looking for? Yeah, I heard it a whisper. Can we say that louder? What are we looking for? The x-intercepts. Okay, so I'm going to graph it. What's the problem? There's no x-intercepts. Do you know why? The answers that we are going to find are imaginary. They're not real. They're not real. They won't show up on the graph. Okay? And that's where completing the square comes in. Okay? So some people are like, oh, well, completing the square can always give me the answer, then that's what I want to do. And that's what we are going to practice today. So again, if you have a real answer, these are great. Okay, when you have non-real answers, then we're going to default to completing the square. We have to. Well, right now we have to. Next week, we will learn another way to solve the equations. So then you'll have 4 different ways. Okay, so the first thing we're going to do is set the equation equal to 0. Okay, so we have x squared plus 10x plus 26 equals 0. Now, when you're completing the square to solve, that's a little different than what we were doing yesterday, because yesterday we weren't completing the square to solve. What were we trying to find yesterday? We were writing equations in what form? Vertex form, right? We're trying to put it in vertex form, and then we were finding the vertex. Here, we're solving. So when you're solving, we got to think to 2.4 day 1, which is where our first step was to subtract 26 from both sides. So you get your x values by itself, and you get your numerical value by itself. Okay, so get your x values by itself, and you get your numerical value by itself. So then from there, now we can complete the square. Because these are on opposite sides, what you do to one side, you do to the other. Yesterday, remember we were working on the same side? We would do the plus and the minus. Now we're going back to this. Okay? All right, so Sam, do you remember what the formula is, like how we fill in that blank? Yes, b over 2 squared. So we're going to take half of the b value. Okay, so if it's 10, half of b is what? 5. And then remember, I like to put this here, like the 5 squared. 5 squared will be 25. So I have this on both sides. Okay, now remember, on this side, you are going to factor. The whole reason why we complete the square is so that we can factor, because this is going to be a perfect square trinomial. Okay? So when you factor, what multiplies to 25 and adds to 10? 5. So it's just x plus 5 squared. Oh, but wait, remember that special pattern? Okay, half of b is always going to be this guy. And then negative 26 plus 25 is going to be negative 1. All right, and then I want you to finish that based on what we did yesterday, okay? Alright, so today remember that we're solving, okay? So when you're solving, if you're balancing the equation, whatever you do to one side, you have to do to the other side. So if I add 25 here, then I'm going to add 25 here because I have to balance the equation. So if I were to subtract 25 from both sides, you guys see how that would cancel out? And I would have the thing I had before. Now, yesterday was a little bit different because yesterday, what side of the equation was I working on? The same side. So the rule is, if you are on opposite sides of the equation, if you're on opposite sides, you do the same thing. Okay, so you got to add. Okay, if you're on the same side, like where this was equal to 0 or f of x, we did a plus and then a minus. So if you're on opposite sides, do the same. If you're on the same side, do the opposite. Is that helpful or confusing? Because they're kind of the reverse, right? So to balance the equation, remember we did opposites because that would add to 0. If you're on opposite sides of the equal sign, then you have to do the same thing because that's what balances it to be 0. Okay, so it is a little bit different than yesterday. Does that help jog your memory about the difference? Okay, so let's go on to the next step here. Okay, so Ava, what did you do next?
So I took the square root of got 1I equals x plus 5.
Good. There's just one thing we're missing. So whenever you take the square root, what do you got to put in front?
Oh, plus or minus.
Yes, good. Okay, so plus or minus. And then did you guys remember from yesterday that the square root of -1 is just I? Okay, great. All right, and then our last step is going to be to move over the 5. Now this is where we want to make sure we have it in the proper form. Okay, so this is in the form a plus bi. So -5 plus or minus I. Okay, so remember, we have the plus or minus because if it is a quadratic equation, how many solutions should I have? 2. Okay, and if one has an I in it, I can't combine those together because they're not like terms. Okay, so when you do this, just complex solutions. Have the form a plus bi. So that's how we're going to write all of our answers there. Okay, great. Now that we've worked through this one, do you guys think that you could do B? I think you can. Okay, so I'll give you a couple minutes to do that. Alright, let's work our way through B. So first step, setting equal to 0, okay? Okay, so x squared plus 4x plus 12 equals 0. And then remember, when you move that over, make sure that you do the subtraction, so it's -12. Okay, and then Kate and G, will you help me fill in my blanks? What did you get for this one? What did we add to both sides? Good. So half of 4 is 2, 2 squared, there we go, awesome. Okay, and then Kate and F, will you tell me what you factored this into? Good, x plus 2 squared equals, okay, and then for this one, because your 12 is negative and your 4 is positive, that's going to be -8. And then if you didn't simplify the square root of 8, will you do that for me? Okay, so Cooper, what did you do here? Good. All right, and then you have x plus 2 equals, tell me what you put on this side. Okay, so you're gonna have your plus or minus, and then the I takes the place of the negative, so it should be I square root of 8. So it can only come out of the square root if it is a perfect square. So if you had 8I, you'd have to have the square root of negative 64. Okay, so the 8's going to stay in there, and I'm going to simplify it. So what's the perfect square that's in 8, guys? 4. So when you simplify this, right, root 4, root 2, this becomes 2 root 2. And then when we write this, it will be 2I root 2. Okay, so put the I behind the 2. That's one of the things to me that's like the nails on the chalkboard, right? If you have a variable like 2x, we wouldn't write that as x2. I's the same. So we don't want to write this as I2 root 2. We want to write it as 2I root 2. Okay? All right, and then x plus 2 is here. So then our final step, subtracting over the 2. And whenever you do that final step, where does this guy go? In the front. Things get kind of confusing when there's this many 2's. So I have negative 2 plus or minus 2I root 2. That's why we just got to do it one step at a time, and then we're ready to rock and roll. All right. Good. How are we feeling about that one? You guys have questions? Okay. If you made it to here, the plus or minus I root 8, that's great. Now we just have to remember we're still simplifying the radicals like we practiced yesterday. Okay? And then for part C, this one is going to be a little bit different. How is this one different than the other two that we did? Yeah, it has 3 in front of the x squared. Do you guys remember what we have to do if there's a number other than 1? Mm-hmm. Good. We have to divide by 3. So we're going to divide both sides by 3. When we do that, make sure that you divide every single term by 3, so it's not just the first term. Okay, so when I'm dividing by 3, I do 3x squared divided by 3 minus 6x divided by 3 plus 10 divided by 3. Oh no, it's a fraction again. All right, so simplify from here. And then once you simplify there, go ahead and do your completing the square. So put your blanks in. Alright, so let's make sure we got the correct thing here. So x squared minus 2x plus 10 over 3. So then we subtract. So now I have x squared minus 2x plus blank equals negative 10 third plus blank. Okay, and then Brianna, will you just tell me what you filled your blank spaces in with? Good. Okay, so half of negative 2 is negative 1, so negative 1 squared is 1. Awesome. And then we have to factor. Okay, so Jack, what does this side factor to? Good. Good job remembering the minus. That's not adding the fraction to the whole number, what do we have to have? Yeah, common denominator. So were you guys able to do that pretty easily? Because what's the denominator? 3. So then you just multiply the denominator by the whole number. And then you can just say, oh yeah, 3 divided by 3 is 1. That's the same thing. So x minus 1 squared is going to equal what? Yes. I'm going to write this nicer. This is where the real fun starts. Okay, so once you get here, Yetta, what are we going to do at this step?
We're going to take the square.
We're going to take the square root, yep. Okay, and then when we're taking the square root, remember, I'm going to go this way so I have room. X minus 1 equals plus or minus, and then we can do I root 7 over root 3. And really, you don't need your parentheses there. All right. So yesterday we talked about how to rationalize the denominator. Okay. Do you guys remember how to do that? Yes. No. Maybe so. Okay. So let's first talk about why we want to rationalize the denominator. Do you guys remember what the purpose is for rationalizing this? What can't we have in a simplified form? We can't have the square root in the denominator, okay? So if it can't be a square root, we want it to be a whole number, right? So we ask ourselves, okay, what can I multiply by root 3 to get a whole number? So basically, the rule with the square root is it just has to have a buddy. Maybe we could call it an identical twin, right? I know you're not an identical twin, but for this, right, it has to be the same. So if it's root 3, we're going to multiply by root 3 over root 3. I can't just multiply the bottom by root 3, but actually, why do I want to do that? What happens when I do the square root of 3 times the square root of 3? To make what? So let's think about the top. Do you know what the top's going to be? Do you know how we can multiply root 7 times root 3?
Multiply 7 and 3.
Yeah, so it's just the square root of 21. So the bottom is the same. If I multiplied root 3 times root 3, what would I get? Yeah, and what does that simplify to? Yeah, that just simplifies to 3. Great. Okay, so the reason why we do that is because this is going to give us a whole number. Root 3 times root 3 is root 3 squared, so it undoes that square. And then my last step is going to be to do what to both sides? Plus 1. So I'm going to have x equals 1 plus or minus I root 21 over 3. Wow. Look how awesome we are. We have fractions, we have square roots, we have imaginary numbers, we have plus, we have minus. There's so much going on there. Okay? What questions do you guys have for me on that one? You guys feel like you can do it if you do it just one piece at a time? Okay? And if you guys need help with rationalizing as you are working, let me know. I'm going to put up your homework on your calendar.